So this is part 2 of lesson 1, and what we will discuss on this lesson, or this part of the lesson, will be Boyle's law, Charles' law, and Gay-Lussac law, and how to define which law are we using. So Boyle's law is talking about the relationship between pressure and a volume when the number of moles and temperature is kept constant. So what did we saw is that P1 V1 over T1 is equal to P2 V2 over T2. And now since the temperature is kept constant, like in the example that we did on part 1, then this is those are canceled out. It's the same value, so those are canceled out. So then Boyle's law turns to be a relationship of P1 V1 is equal to P2 V2. In other words, the product of pressure and volume is constant when the number of moles, or the amount, and the temperature is constant. Now, let's see how this relationship can be translated into a graph. So if we have a graph, if we graph this volume, pressure, or pressure versus volume, what we will see as a graph is this one here. It's a line that it has both axes as the asymptote. So now what do we see, since this product of P and V is constant for given conditions, that number of moles and temperature are kept constant. That means that if we increase the volume, then we have to decrease the pressure. Or if we decrease the volume, then we have to increase the pressure, okay? Because the product of the two has to be constant, has to be the same. So this is what the line looks like, or the pressure versus a volume looks like. But even if we draw volume versus pressure, we will have the same graph. So volume versus pressure will have the same type of line, like this. Okay, so now as the pressure increases, volume will decrease. And in this case, as the volume increases, the pressure will decrease. Okay. So this is in terms of the graphs, how the graph look like. Now, a sample. Oh, let's do some more here. So what do we have here is P1 V1 is equal to P2 V2, or the product of pressure and volume is constant. So if you increase the volume by a factor of 2, then what will happen, so volume is increased by a factor of 2, then what will happen with pressure will be decreased by the same factor. Or if you increase the volume by a factor of 3, then what will happen with pressure is will be decreased by a factor of 3. Or if you decrease the volume by a factor of 3, then pressure will increase by a factor of 3. Or if you decrease the volume by a factor of 4, meaning that you multiplied by 1/4, then pressure will be increased by a factor of 4. So this is telling that pressure is inverse proportional of volume. You increase the volume, decrease the pressure, okay? Or even this one here, the second graph, volume is direct proportion of the inverse direct proportion of pressure. You increase the pressure, decrease the volume. Okay. Let's take a look at this sample here. A sample of carbon dioxide gas has a volume of 15 liters at 110 kilopascal. What must the pressure be to increase the volume to 12 liters? So V1 is 15 liters, pressure 1 is 110 kilopascal, and then V2 is 12 liters, and we are looking for P2. So we start with Boyle's law, P1 V1 equals to P2 V2. From here we find that P2 is equal to P1 V1 over V2. Substituting what do we have here, 110 kilopascal times 15 liters over 12 liters. So liters and liters is cancelled out. The units that we will end up having is kilopascal, and the value is 138 kilopascal. So this is what the pressure has to be in order to have a volume of 12. As you see here, the volume is decreased and the pressure is increased. Let's take a look at the second example when we have a sample of methane gas with a pressure of 105 kilopascal and a volume of 25 liters. If the pressure is going to 95, is decreased now, 95 kilopascal, what is volume 2? So now, see, if the pressure is decreased, what are you expecting that the volume will be? Will be an increase. Okay, so P1 V1 equals to P2 V2. From here, we find that V2 is equal to P1 V1 over P2. Substituting what we have is 105 kilopascal times 25 liters over 95 kilopascal. So kilopascal and kilopascal is cancelled out, and then we'll have 27.6 liters. As you see here, from what we said is that the volume is increased in comparison to the initial one. Okay, now let's see what will happen on this case here when 30.7 liters of sample of hydrogen gas is, so volume 1 is 30.7 liters, is at a pressure of 590 mmHg. The sample volume drops to, so V2 is 25.6 liters. What do you think that the pressure will be? Is an increase or is a decrease? And then we want the pressure in the value of the pressure in kilopascal. Okay, so now since the volume is decreased, the pressure will be increased based on what we said. The pressure will be increased. And now let's calculate P1 V1 equals to P2 V2. From here we find that P2 is equal to P1 V1 over V2. And on this case, I will keep the answer into mmHg and then convert it, or leave it up to you to convert it. So we'll have 590 mmHg times 30.7 liters over 25.6 liters. So liters and liters is cancelled out. P2 will be 708 Hg. As you see here, it is an increase from 590 into 708, and now your job is to convert it to kilopascal using what we said in the previous part of the lesson. Okay, so this is in terms of Boyle's law, and now when we are talking about Charles' law, what the relationship that Charles managed is between volume and temperature at a constant number of moles and pressure. So if we refer again to the combined law, P1 V1 over T1 equals to P2 V2 over T2. Now what do we have is a volume pressure is the same, so P1 equals to P2. Therefore, we can cancel that out. Okay, and then what do we have is the ratio of the volume over the temperature is constant, which means that V1 over T1 is equal to V2 over T2. Okay, in terms of what is happening with explanation of how is this represented to graph, and so what we have is that volume versus temperature graph. So volume versus temperature will look like a straight line. Okay, so it's like this. Let's make it with another color. So it will be like this. Okay, so what we see here as the volume is increased, the temperature will increase as well. And even if we draw the temperature versus volume graph, we will have the same thing. A graph that looks like this, which means that as you increase the temperature, the volume will increase as well. Or if you decrease temperature, so if you decrease temperature, the volume will decrease as well, and vice versa for the other graph. So this means that the relationship between temperature and volume at constant amount and pressure is proportional. So the relationship between temperature and volume at constant amount, which in formula is translated as the number of moles, and pressure is proportional. So in other words, as the temperature is increased, the volume will increase as well. Or if the temperature is decreased, the volume will decrease as well. Okay, you can even say vice versa, that temperature is direct proportion of the volume, which means that if the volume is increased, the temperature will be increased as well. Or if the volume is decreased, the temperature will decrease as well. Okay, let's take a look now to this example here. A sample of helium gas has a volume of, so volume of 445 liters at a temperature of 30 degrees Celsius, which we converted into Kelvin. So 30 plus 273.15 equals to 303.15 Kelvin. And then it is heated up. And what is the temperature 2 when the volume is 500? Volume 2 is 500 liters. So we will start with V1 T1 equals to V2 T2, which tells us that T2 will be V2 T1 over V1. And then plotting whatever we have here, 500. First of all, since the volume is increased, you are expecting that the temperature will be increased as well. So 500 liters times 303.15 over 445. So T2 will be in Kelvin, 341 Kelvin, or just to check and to see if we are right, if the temperature is increased, 67.5 degrees Celsius, which is an increase from what we started with. So this kind of gives us the confidence that what we have done is right. Okay, so you check it and then you see the logic that's done behind that. Now, a balloon is filled with hydrogen gas at a temperature of, so T1 equals to 325 Kelvin and has a volume of 14 liters. The balloon is cooled and causing the volume to decrease, V2 of 9.0 liter. What is the temperature in degrees Celsius? Okay, so now you are expecting that the temperature will be lower, and that our calculations will prove it. So T2 will be V2 T1 over V1. So this will be 9 liters times T1, 325 Kelvin over V1 is 14 liters, and liters will cancel out. So then we will have a temperature in Kelvin of 208.92 Kelvin. If we convert it into degrees Celsius, then we'll go 208.92 minus 273.15, and this will be equals to negative 64.2 degrees Celsius. So that means that the temperature is decreased. Is decreased by a lot, actually. Okay, because we know that the temperature is direct proportion of volume. So if you increase that, we'll be increasing the volume, then we'll be increasing the temperature. Okay, so now we have sample of 3.0 liters of oxygen gas held at SATP conditions. The volume is increased to 5.0 liters. What are you expecting that the temperature will happen is an increase, because it is a proportional relationship. So when you increase the volume from 3 to 5, then you should expect an increase on temperature as well. Now, what is the new temperature of the gas? So let's sort what it is given. 3.0 liters for volume, and then we have SATP conditions. So we have a certain pressure, temperature, and molar volume. But what we are worried about is the temperature. So T1 will be 298.15 Kelvin. And volume 2 will be 5.0 liter. So we are looking for temperature 2. temperature 2 will be V2 T1 over V1, and this will be 5.0 liters times 298.15 Kelvin over 3.0 liters. So liters and liters is cancelled out. So temperature will be 497 Kelvin or 224 degrees Celsius. If the question is asking you for Kelvin, then you have to record 497. And if it is asking for the degrees Celsius, then you have to record the 224 degrees Celsius. Guy-Lusiak law manages the relationship between pressure and temperature when the number of moles, or the amount, N, and volume is kept constant. Okay, so now what do we have? If we start with combined law, P1 V1 over T1 equals to P2 V2 over T2. Now what do we have is a volume is constant, so V1 is equal to V2, which means that they will cancel out, and then we will have a relationship as P1 T1 is equal to P2 T2, or the ratio of pressure and temperature is kept constant, which means that they are the same logic as we had for the volume and temperature. They are direct proportion of each other. If you increase the pressure, you have to increase the temperature, and if you decrease the pressure, then you decrease the temperature. Or if the pressure is increased, then you should expect that there is an increase on temperature as well, or if the pressure is decreased, then you should expect a decrease on pressure as well. So now let's see, what do we have here? We have a pressure, determine the pressure change when a constant volume of gas, so volume is constant, is at 1.0 atmosphere, is heated from 20 to 30. So as you see here, the temperature is increased, which means that we should expect that there will be an increase on pressure as well. Anyhow, what we have is P1 T1 is equal to P2 T2. Now what is given here, let's write what is given. P1 is 1.0 atmosphere and T1 is equal to 20 degrees Celsius. And when we convert it into Kelvin, will be 293.15 Kelvin. And P2 is known, and T2 will be 30 degrees Celsius. So 30 plus 273.15 will be 303.15 Kelvin. So now what we are looking for is P2. Then P2 will be P1 T2 over T1. So this will be 1 atmosphere times 303.15 Kelvin over 293.15 Kelvin. So Kelvin and Kelvin is cancelled out, and P2 will be 1.03 atmosphere, which is a number that is higher than 1.0 atmosphere, and it is telling us what is the like it's giving us that what we are doing is right. It's giving us the confidence, we should say, that what we are doing is right, because we were expected that the temperature will be increased. Let's take a look at this other example here. Oh, by the way, if they're asking you for kilopascal, then you convert it into kilopascal. Now, next example is saying that a gas container is initially at a pressure of 47 mmHg, and what will the pressure be? So P2 is if the temperature goes to room temperature, so from T1 of 207 Kelvin into T2 of 25, which is the room temperature, plus 273.15 to convert it into Kelvin, which is 298.15 in Kelvin. So now we start with P1 T1 equals to P2 T2. And from here we find what is P2. So it will be P1 T2 over T1, or P1. Now we are not changing any units here. We are keeping the same because the units will either cancel out or we will have the units of mmHg for pressure. And if they are asking you to convert it into a different one, then use the conversion ratio and convert them. 47 mmHg times 298.15 Kelvin over 207 Kelvin. So Kelvin and Kelvin is cancelled out. Then pressure 2 will be 68 mmHg. And as I said, like, we are not converting it into another unit, but if the question is asking you to convert it into another unit, then go ahead and use the conversion ratio. Now, what do we have here is that a gas thermometer measures temperature by measuring the pressure of the gas inside a fixed volume container. A thermometer reads a pressure of 248 kilopascal at 0 degrees Celsius. So T1 0 degrees Celsius is 273.15 Kelvin. Now, the pressure increases to thermometer, so P2 is 345 kilopascal. What do you think that the temperature will be? Will be increasing or decreasing? And what is the temperature? So now, since the pressure is increased, then the temperature will increase as well, because they go proportionally of each other. And now what do we have is T2 is equal to P2 T1 over P1. Then we will have 345 kilopascal times 273.15 Kelvin over 248 kilopascal. So kilopascal and kilopascal is cancelled out, and the temperature will be 380 Kelvin. And you may convert it into degrees Celsius. But what do you notice here is that the temperature is increased in comparison to what we started with. Okay, so this is the summary of the gases now, gases law. So what do we have here in terms of the equation for the combined law is P1 V1 over T1 equals to P2 V2 over T2. Sometimes we see it P1 V1 T2 equals to P2 V2 T1. This is the equation. And what do we have here is that VT, so VT is direct proportion of the inverse pressure, or you can say that pressure is direct proportion of the inverse of the product Vt. And what is kept constant in combined law is the amount of gas or the number of moles. For Boyle's law, what do we have as the equation is P1 V1 equals to P2 V2. What do we have in terms of the relationship is that P is direct proportion of the inverse of V, or you can say that V is direct proportion of inverse P. And what is kept constant here is temperature and amount, or the number of moles. Okay. Now, next one is Charles' law. So on Charles' law, what do we have is V1 T1 is equal to V2 T2. Sometimes you see it as, let's change the color here to blue. Sometimes you see it as V1 T2 equals to V2 T1. Okay. What we have in terms of the relation is that volume is direct proportion of T, of temperature, or you can say that temperature is direct proportion of V. So when you increase this, increase this. And what is kept constant here is pressure and the amount, which is represented by the number of moles. I want you to find this or complete the last column here for Guy-Lusiak law, and then we will move to the examples to see which one do we have to choose in order to, which law do we have to choose when a bunch of questions are given to us. So the first example is saying that we have a volume of 300 milliliters at a temperature of 17 degrees Celsius. What is the volume? So V2 question mark at a temperature T2 10 degrees Celsius, T2 10 degrees Celsius. So if we list what is given, then we will have V1 at 300 milliliters. Temperature 1, I will convert it into Kelvin, so 17 plus 273.15 will be equals to 290.15, I believe. And then T2 will be 10 degrees Celsius plus 273.15 will be 283.15 Kelvin, and we are looking for volume. So then what do we have to use is Charles' law. Why? Because Charles' law is saying V1 T1 is equal to V2 T2. And since pressure is not mentioned, that means that, and the amount is not mentioned, that means that they are kept constant. From here, we find that V2 is equal to V1 T2 over T1, or 300 milliliters times 283.15 Kelvin over 290.15 Kelvin. So Kelvin and Kelvin is cancelled out. Then we will have 293 milliliters, which is lower than the start, or 0.293 liters. So you will sort what is given, and then you will see what is the assumption that is made here. And then based on that, you will pick the correct law. For each of the word problems, state the gas law and determine the equation to determine the unknown. Okay, so now what do we have here as a volume? So volume 1, 586 liters at a temperature 1 of 25 degrees Celsius, which when we convert it into Kelvin will be 295.15, 98.15 Kelvin as T1, a capital T because we are dealing with Kelvin. And then the T2 will be negative 25 degrees Celsius plus 273.15 will be equals to 243.15 kelvins. Then, as you see here, there is pressure is not mentioned. The number of moles is not mentioned. So then what we have to use is Charles' law. V1T1 equals to V2T2. And then from here, we will solve for V2 equals to V1T2 over T1. Okay, so then after we say 568 liters times 248.15 over 298.15 Kelvin. Kelvin and Kelvin is cancelled out, will be 473 liters, and it is a number that is lower than what we started because the temperature is lower. Okay, let's move now to the next one, 252 milliliters of chlorine gas. So volume 1 is equal to 352 milliliters. You don't need to convert it into liters. It's under the pressure of P1 680 mmHg, are placed in a container under pressure 1 to 10 mmHg. The temperature remains constant at, so temperature is constant, then what is the volume? So volume 2, then what we do is we will use Boyle's law, because the temperature is constant and the amount is constant. So then what we have at Boyle's law is P1 V1 equals to P2 V2. From here, we find that V2 is equal to P1 V1 over P2. So we'll have 680 mmHg times V1 is 352 milliliters over 1210 mmHg. So this is cancelled out. Then the V2 will be 198 milliliters, or if we write it into liters. And even as you see from the calculations here, we can say that the volume is decreased in comparison to what we started with. Okay. Again, what we are doing here is we are defining which equation are we using. So we have we have 652 milliliters to 40 degrees Celsius and 720 mmHg. What volume will the sulfur dioxide occupies at SATP condition? So what is given here is, I will write it here, V1 is 652 milliliters at temperature 140 degrees Celsius, but when we convert it into Kelvin, will be 313.15 Kelvin, because 40 plus 273.15 will be this one here. And then we have a pressure of 720 mmHg. Okay, so now we are dealing with STP conditions, which tells us that volume 2 is unknown. Temperature 2 will be 273.15 Kelvin, and then the pressure will be 101.325 kilopascal, or 760 mmHg. So this will be pressure 2. Now, since we are dealing with volume, change of temperature, change of pressure, that means that what we will do is the combined laws of P1 V1 T1 equals to P2 V2 T2. And then from here we will find what V2 is. So it will be P1 V1 T2 over P2 T1. Let's substitute what is given. So it will be 720 mmHg times 652 milliliters times temperature 2 will be 273.15 Kelvin over the whole thing will be P2 is 760 mmHg times 313.15 Kelvin. So Kelvin is cancelled out, mmHg is cancelled out, then volume 2 will be 539 milliliters or 0.539 liters. Okay, so this is how we decide based on the information that is given in the question, what is the law that we will use, what is the formula that we will use. So now let's see this one here. 20-liter container is filled with helium at a pressure of, so we'll sort here what is given and what they are asking for. So what is given is volume 1 is 20 liters. Pressure 1 is 150 atmosphere. And pressure is volume 1. And then we have how many 5.0 liters balloon can be filled when the temperature is T2 equals to, so what is the volume are asking? So what is volume V2 when pressure 2 is 755 mmHg and temperature 2 is 22 degrees with degrees Celsius, which means converted it into Kelvin. 22 degrees Celsius will be 295.15 Kelvin, while the temperature 1, this one here, and the temperature of 30 degrees Celsius, so this will be 303.15 Kelvin. Okay, as you see here, we are dealing with a combined law because P, V, and T are changing. The only one that is not changing is the amount. Okay, so now if we have, and the units are not the same. So let's convert first P2 into atmosphere. And what we are doing is we are using the ratio of 1 atmosphere is 760 mmHg. So P2 will be 0.9934 atmosphere. Okay, so now P1 V1 over T1 equals to P2 V2 over T2. And then from here we find that V2 is equal to P1 V1 T2 over P2 T1. And after substituting everything and the pressure to on atmosphere, we will have 2,940 liters. Now, if each balloon is able to carry 5 liters of gas, then 2,940 liters, one balloon is able to carry 5 liters, so liters per liters is cancelled out, then you are able to fill 588 balloons. Okay. And now let's move to the next one. A gas has a volume of 600, so volume 1 is equal to 600 milliliters. And what is the new volume if the pressure, so V2 is question mark, if the pressure goes from 90, P1 equals to 90 kilopascal, to P2 150 kilopascal. So what the law that you have to take into the consideration here is Boyle's law. Why? Because in Boyle's law, the temperature is kept constant, and here is nothing mentioned about the temperature, and the amount is kept constant. Again, we know now from the wording of the question. So the law is Boyle's law, and what are we expecting that will happen here? Since the pressure is increased, then we should expect a decrease. And when we find the volume, is P1 V1 equals to P2 V2. And then from here, V2 will be P1 V1 over P2. So then we'll have 90 kilopascal times 600 milliliters over 150 kilopascal. So kilopascal and kilopascal is cancelled out, and then we have 360 milliliters or 0.3660 liters. And as we see here, the volume is decreased from 600 milliliters to 360 milliliters. This is the end of lesson 1. Now you should complete the assignment on lesson 1, and if we have any question, we will deal with it